Alright, what we're going to look at is equations and how we can manipulate them to help to solve what we want to solve for. If we look here, we've got y plus 4 equals 6. We can manipulate this pretty easily with numbers by solving for y. To solve for y, we just want to get y alone. If I subtract 4 on both sides, I'll get y is equal to 2. That's what we've been doing. Now we're stepping it up a little bit. And we're just going to solve in terms of variables. Now we said variables have the same value as numbers, or I'm sorry, the same properties as numbers. They just don't have any values to associate with. So we can do everything we would do with a number with a variable, except we just don't have a finite number to plug in and solve for. If we look up here, V equals IR, that would be Ohm's law. We've talked about Ohm's law in class. Ohm's law is a law that relates voltage to current and resistance. So we've got V equals I times R. Now, we're not always just looking for voltage. Sometimes we'll have a problem where our resistance is given, our voltage is given, and we want to know what the current is that's flowing through that circuit or through whatever it is that we're working with. Now, if we want to do that, that means we want to solve for I. We want to get I alone, which we can do. So if we set it up, this is what we know. We know that our voltage is equal to our current times our resistance. If I have a resistance and I have a voltage and I want to find current, that means I want to get this I alone. To get this I alone, I've got to get rid of this times R. Again, properties of numbers. To get rid of a times number, we divide by that number. So to get rid of times R, we're just going to divide by R. Whatever I do on the right-hand side, I've got to do the left-hand side. These R's are going to cancel out. We'll see that our current is going to be equal to our voltage divided by our resistance, which is simple enough. Now, same thing could happen if we have a problem where we have a voltage and we have a current. We want to know the resistance. Doing the same thing, except now we're solving for R. So if our voltage, we said Ohm's law, voltage is equal to current times resistance, except this time I want to solve for resistance so I can plug in and find what that missing resistance is. Got to get rid of this times I. To get rid of a times I, just do the inverse, which would be divide by I. These two are going to cancel. My resistance is equal to my voltage divided by my current. So it's pretty simple with Ohm's law, just a one-step kind of inverse operations, and we can solve. A little bit more complex, if we're trying to solve for y here, we're going to do the same thing we would do if we had numbers. We want to eliminate all of those variables until we only have y on the left-hand side. So the first thing I want to get rid of here would be this b. And remember, this line is a division line, so I've got divided by b. To get rid of divided by b, I want to multiply by b. Let's see if these two are going to cancel out, top and bottom. Do the same thing on the right-hand side. I've got to multiply by b. Remember, these are the same properties numbers would have. So now if I rewrite my equation, I've got a times y plus x equals, and I'm just going to call it cb, because I know I'm multiplying those two. Now I've got to get rid of that a. A couple different ways you could do it. If you distribute, that will help you to simplify, but that's actually going to create one more step for you. So I'm going to get rid of that a. I know that this a is being multiplied by this whole function here. So I'm going to divide it. I'm going to get rid of that a. I don't want to mess with it anymore. Divide by a on both sides. See, these a's are going to cancel out. I've got y plus x is going to equal c times b divided by a. Now, the end is near. I could see the only thing I have over there is y plus x. All I got to do is subtract an x. And I've got my y alone. Y would be equal to c times b over a minus x. So really all I'm doing is undoing that equation until I get whatever variable is desired alone. In this case, it was y.